Space, the final frontier, where our Earth is the center of the universe, where all orbits are perfect circles around us, and where each has a perfect constant velocity, also known as the geocentric model of the universe. Breaking news, Orbital Man is born.
On this day, 27th December 1571, Orbital Man, also known as Johannes Kepler, was born in Württemberg, Germany. A man from humble beginnings, he studied at the University of Tübingen. During this time, he was introduced to the work of Copernicus, who first proposed the heliocentric model of the universe. After university, he became a professor of mathematics in Graz, Austria. Eventually, he moved to Prague to work with Tycho Brahe and inherited his post as imperial mathematician. Even though he was incredibly intelligent, Kepler could never overcome humanity's kryptonite, death. However, before his death, he achieved a great many things, including Kepler's laws of planetary motion.
Kepler's first law of planetary motion states that planets move around the Sun in ellipses with the Sun at one focus. This essentially describes the orbit of a planet as an elliptical path. Kepler's second law of planetary motion states that the line connecting the Sun to a planet sweeps equal areas in equal times. That is, it takes the same amount of time to move along every arc distance. Therefore, a planet moves faster when it's close to the Sun as it must cover a larger distance over the same period, which can be seen here. Kepler's third law of planetary motion states that the square of the orbital period of a planet is proportional to the cube of the mean distance from the Sun, that is r cubed equals t squared. So if you look at the graph here, you can see that r cubed over t squared gives us a constant value.
Kepler derived these ideas through his belief in the heliocentric model and the analysis of observations made by Tycho Brahe. At the time when Kepler proposed his ideas, the government and society were heavily influenced by the Christian religion, which believed in the geocentric model. Since he had no mathematical proof, people refused to believe him, and it led to him being kicked out of the Lutheran Church. It wasn't until 1687 that Isaac Newton mathematically proved Kepler's ideas to be true for all orbital systems. This was the moment when they were no longer ideas, but now mathematical laws.
Regarding the impact of Kepler's laws on society today, the biggest impact has been on space travel. Everything that is launched of the Earth into space for orbit relies on Kepler's laws of planetary motion. Looking at Kepler's third law, we can see that the mass of the Sun can be substituted for the mass of the object being orbited. And from this we have made vast technological advances through the development of satellites.
Some of these have allowed the development in fields such as navigation and communications, while others, which orbit other planets and systems, gather information to show us more about our universe. Likewise, these laws are vital to manage space travel for objects such as the International Space Station and the Hubble telescope. Ultimately, without Kepler's laws, the space age would never have happened, and we wouldn't have much of the technology that we have today.
This has been the life, the death, and the impact of Johannes Kepler, the Orbital Man.
MATH187 Breaking News, signing out.